Hello, my dearest Bakchas. I know. Exams are just around the corner and the tension is building up. But don't you worry, because I am here to help you. Today, we're going to do a super quick, super fun revision of a chapter that everyone thinks is tough but is actually a piece of cake. Or should I say, a slice of pizza? Let's get started with areas related to circles.
Alright, let's jump right in. Now, I've seen the diagrams in this chapter. They can look a little scary at first, right? But trust me on this. It all boils down to just two simple ideas. Once you get these two ideas, the whole chapter is going to feel like a walk in the park. And to understand this entire chapter, you only need to think about one thing: pizza. Yes, you heard me right. The whole secret to mastering sectors and segments is hidden inside a delicious cheesy pizza. So you know that single slice of pizza that you love so much? Well, in the world of mathematics, that has a fancy name. We call it a sector. It really is as simple as that. Now, let's just quickly look at the official definition. Okay, so the textbook says it's the region enclosed by two radii and an arc. But forget all that textbook language. Just think about your pizza slice. The two straight sides of the slice, those are the radii. And that yummy, crusty part at the end, that's the arc. See? You already know what a sector is. So the big question is, how do we find the area of just one slice? Instead of just memorizing a formula, let's be smart about it. Let's build it ourselves. It's just common sense, really. We all know a full circle is 360 degrees, and its total area is pi r squared. Now, let's use the unitary method. You remember that from 6th standard, right? If the area for a full 360 degrees is pi r squared, then what would the area for just one tiny little degree be? Exactly, it would just be the total area divided by 360. Simple. And from there, it's just one final step. If you know the area for 1 degree, then to find the area for any angle, which we'll just call theta or theta, you just multiply. So the area of a sector is theta over 360 multiplied by pi r squared. And just like that, you figured out the formula all by yourself. Well done. Now, what if you don't want the area of the whole slice? What if you only want to know how long the crust is? You know, the best part for some people. That's called the length of an arc. And the logic is exactly the same. The total crust of the pizza is just the circumference, which is 2 pi r. So for our angle theta, the length is just theta over 360 times 2 pi r. Easy peasy. Okay, theory is all well and good, but maths is about doing, right? So let's solve a very simple question, straight from your textbook. This will really lock the idea in your brain and give you a nice confidence boost. Grab a pen if you want to solve it with me. Okay, here we go. The question gives us a radius of 4 centimeters and an angle of 30 degrees. All we have to do is pop these numbers into our beautiful formula. So theta is 30, r is 4. That's 30 over 360 times 3.14 times 4 squared. You do a little bit of calculation and you get approximately 4.19 square centimeters. Simple as that. All right, you are now a master of sectors. So let's move on to the second and, believe it or not, the final big idea in this chapter. It's called the segment. And for this, let's go back to our pizza. Imagine you've eaten the cheesy, pointy part of the slice. What are you left with? That leftover crusty bit at the end? That, my friends, is a segment. The official definition says it's the region between a chord and the arc. A chord is just that straight line you'd get if you cut the crust off. So basically, it's the last bite of the pizza. Let's put them side by side so there's zero confusion. A sector is the whole pizza slice, shaped like a V. A segment is just the crusty end, shaped like a D. So remember, sector is the slice, segment is the crust. Got it? Good. So how do you find the area of this crusty segment? Well, the formula is so logical you'll laugh. You just take the area of the whole slice, the sector, and you subtract the area of the triangle part that you ate. That's it. Area of segment equals area of sector minus the area of the triangle. Now for a slightly bigger problem from your book. Don't look at the big numbers and get scared. We're not going to get scared. We're going to break it down into teeny, tiny, simple steps. You and me together. Let's do this. Here is our master game plan. It's a simple 3-step attack. First, we find the area of the whole slice, the sector. Second, we find the area of the triangle. And third, we just subtract number 2 from number 1. That is it. Okay, so here's what they've given us.
a radius of 21 centimeters, and a pretty big angle of 120 degrees. Our mission, should we choose to accept it, is to find the area of the segment. Let's start with step 1.
Step 1. Area of the sector. We use our formula, theta upon 360 times pi r squared. So 120 over 360 times 22 by 7 times 21 times 21. We do a little bit of magic cutting here and there, and boom, we get exactly 462 square centimeters. Step 1, done and dusted.
Now for step 2, the area of that triangle. Now, this part uses a little bit of trigonometry to find the base and height. But for this quick revision, let's just use the value they calculated in the textbook, which is 441 times the square root of 3, all divided by 4. And just like that, step 2 is also finished. And now for the grand finale, step 3. We just subtract the area of the triangle from the area of the sector. So it's 462 minus that triangle area. And that is our final answer. You can just leave it like that, no need to simplify it further. You did it. It wasn't as hard as it looked, was it? We've covered everything. Now, for what I think is the most important part of this whole revision, I have made a master formula sheet for you. Please, Beta, get your fingers ready and take a screenshot of this next slide. It will be very, very helpful for your last-minute revision. Here it is, everything you need, all on one screen. The area of a sector, the length of an arc, and the area of a segment, along with their formulas and our little pizza trick to remember them. This is your secret weapon for this chapter. Keep it safe. But before you go, one last little challenge for your brain. It's a multiple-choice question from your exercise. Now be careful, they've changed the letters to P for the angle and capital R for the radius, just to try and confuse you. Read the options very carefully. Which one is it? I'll give you a moment. 3, 2, 1. The correct answer is D. Did you get it? This one is a little bit tricky. Our formula is P over 360 times pi r squared, which is not even an option. So what did they do? Look at option D. They just multiplied both the top and the bottom of the formula by 2. So sneaky. It's a common way examiners try to confuse you, but you are all way too smart for that. You are prepared, you've got this, and you are going to do wonderfully. All the very best for your exams, my butchas.